Next, name and section. This is taking so long. When is the last guy?
Workplaces and social events frequently require a method to monitor guests or employees' attendance. Implementing such a significant system can be done in a number of ways, from using conventional pen and paper method to utilizing contemporary digital technologies like barcodes and biometric authentication. However, each of these approaches has its respective disadvantages. In short term, the conventional pen and paper method might be inexpensive, but over time, continuous procurement might be costly and environmentally unsustainable. Barcodes are susceptible to damages from frequent use, can be falsified, and depend on line of sight. While biometric authentication systems are not only costly to install, but also present ethical and legal questions around their usage and storage of biometric data. A solution that avoids these drawbacks must be explored. Radio frequency identification, or RFID for short, is a method of wireless communication that uses electromagnetic waves to identify and track tags attached to objects, people, or animals. This technology has multiple applications, including, but not limited to, livestock tracking, point of sale systems, and supply chain tracking. In this video, our group will present a attendance tracking system that uses RFID technology as its method of identification. Such a system can avoid the pitfalls of above mentioned approaches. An additional feature of the system would be a software application that leverages Microsoft Excel to store attendance data, such as names and times of arrival, as well as read Excel files to register the unique hexadecimal codes that RFID tags contain and the names of the individuals associated with those tags.
The objectives of this project are as follows. First, to design, develop, and implement an RFID-based attendance system. This system will have hardware and software components. Next, this system must prioritize ease of use for both attendees and system operators. And lastly, system installation must be simple and not require specialized skills. The application developed for this system has the following functionalities and methods. The program execution begins with the RFID scanner constructor, which initializes the application by calling the create GUI and initialize serial port methods. This sets up the user interface and configures the serial port for communication. The create GUI method sets up the graphical user interface. It creates the main window, adds buttons for user interaction, and a text area for logging messages. It also sets up action listeners for the buttons to handle user inputs. The initialize serial port method is called to configure the serial port settings. It checks for available ports, sets the baud rate, and prepares the port for communication. If no ports are available, it logs an appropriate message. When the user clicks the Select Excel File button, the Select Excel File method is called. This method opens a file chooser dialog, allowing the user to select an Excel file containing student data. The selected file is then set, and its path is logged. When the user clicks the Set Log Directory button, the Set Log Directory method is called. This method opens a file chooser dialog to allow the user to select a directory for saving the log file. The selected directory is set and logged. When the user clicks the Set Log File Name button, the Set Log File Name method is called. This method opens an input dialog prompting the user to enter a name for the log file. The log file name is updated and logged.
When the user clicks the Start Listening button, the Start Listening method is called. This method starts a new thread that continuously reads data from the serial port. The received data is appended to a string and processed when a new line character is detected, indicating the end of an RFID scan. As part of the Start Listening method's execution, it sets its listening to true and begins reading data from the serial port in a separate thread. This ensures that the GUI remains responsive while data is being read. When an RFID scan is completed, indicated by a new line character in the received data, the processed RFID method is called with the scanned RFID as an argument. This method processes the RFID to find the matching student name in the selected Excel file. The process RFID method uses a depth-first search (DFS) algorithm to search for the scanned RFID in the Excel file. It reads the file, pushes all rows into a stack, and pops them to search for the RFID tag. If a match is found, it logs the student's name and calls the log attendance method to log the data. The log attendance method appends the scanned RFID, the student's name, and a current timestamp to the log area (JTEX area). This provides a record of the scanned data for the user to review. When the user clicks the Stop Listening method, the Stop Listening method is called. This method stops the thread that reads data from the serial port by setting its listening to false and closing the serial port. This Stop Listening method ensures that the serial port is properly closed and logs that the listening process has stopped. After stopping the listening process, the Save Log method is called to save the log data to an Excel file. This method creates or opens the log file and writes the RFID, name, and timestamp from the data from the log area to the file. Throughout the program, the log string message method is called to append messages to the log area (JTEX area). This provides real-time feedback to the user about the system status and actions. The main string open close square bracket argument method is the entry point of the application. It launches the application by creating an instance of the RFID scanner class using swing utilities.invoke later. This ensures that the GUI is created and updated on the event dispatch thread (EDT).
Let's move on for the hardware. For the device that will scan the RFIDs, these are the parts used. The components used to read the RFID is an RC522 RFID module. When an RFID is scanned, this module will pass on the data to an Arduino Uno microcontroller, which will then pass on the data to a connected computer that has the application software. If the RFID scanned is a registered RFID, the apps will log the information and the RFID module will start scanning for another RFID. The LCD will display the RFID of the student and will go back to the waiting for RFID screen after 1 second. This is to ensure that the scanning will be continuous and not interrupted. To demonstrate how our system works, we will provide it with two different inputs. The first is our positive test case, an RFID that has been registered by the application, and the next is our negative test case, an RFID that has not been registered. Now let's proceed to our demonstration. Here we see is the IDeaScanner application. We first select an Excel file which contains the students. Let's say we have here the RFID test 2, which has these kinds of variables from our RFID and the names of the student, and then let's select its log directory. Let's say it's also going to be the desktop, and its name is going to be OPProj1, and then we start listening. As you can see on this side, you could scan an RFID, you say my RFID, my school ID, and then it will just display this. And see, scans and it will display it. And if we stop listening, it will save the log here. See, I've scanned in uh, today, 19 and 14, 2 to 47 p.m. and my RFID here. So what if we like scan an RFID that isn't on our schedule, like on our lists? Let's see, documents, desktop. Let's choose this one. It contains this. It doesn't have my IDs, RFID. And let's set the log directory onto the desktop as well. And its file log name as op branch 2. And let's start listening to it again. As you can see, it says not found in the Excel file. See? And if we stop listening, it says it saves the log, but here we have the log. It doesn't have anything because it didn't register the name and its RFID. So that's it.